This is my van here, Dean. 1996 minivan, Ford Windstar. I do about 200 miles a day. It's a good little car. Just explain something we're burning on this kind of. Yeah. Okay, come here, Dean. You're showing us up in front. Okay. This is, take a picture of my certificates here. This here's my diploma from the University of Utah. I went to 3 different universities and graduated from the University of Utah. I'm a highway engineering technician. And this is a certificate from the federal government to test painting on bridges. And then there's one for culvert pipe. And last year I won some incentive awards for different new ideas. And we test rebar for all our bridges here. What we do is we put them up in here, we bust them right in half. You can see that one's busted right in half. We take, and then we bend it on the bender here. Bender, 180 degrees. And here's one that's bend 180. 180 degrees. And then we test these concrete cylinders right here, and we push down on the press, and we have to calculate the area, and you have your load here on here, and you divide your area into your load, and it gives you your pounds per square inch. Okay? And the formula for that is diameter squared times pi divided by 4. That gives you your area. And so we get about 5,000, 6,000 psi on our concrete cylinders. On our rebar, we have a chart here, and the area is already calculated out. So for that number 11 bar, that big bar I showed you for our bridges, those big ones hold up the whole bridge. It's 1.56. We divide 1.56 into a load, and the minimum is 60,000 pound load. The ultimate load is 90,000 pounds. And PSI, I mean. Now, we also check bolts here. What we do is we grind them off here, grind it off here, and we put it on a diamond tip here, and it tells you how strong this bolt is before you even test it to see if it's hard enough or soft enough to work with.
Is that a GR70 bolt?
This is a Rockwell hardness tester, and
is that called an L9 bolt? About the hardest you can get?
Yeah, these are the hardest ones we get. Okay. These are 325 bolts for bridges. And we have all kinds of different sizes. Mm-hmm. And then we put it in here, and we got
how many stars has that got?
There's no stars. This is just
5.
It's a 325. It has 325 stamped on it. This is a torque tester, and we torque these bolts up to 38,400 pounds, and we have a calibrated washer, and we use these calibrated washers with nibs on it. And when the nibs get compressed, then we know we got enough torque on the bolts, and that's how we calculate the tension on the bolts on our bridges. We also take these bolts And we put the bolts inside here like this. We put the nut on the other end. And then we put them in these fixtures and we put them on the press and we pull them and bust them right in half. So we have to test the bolts and the washers before they're used on our bridges. Okay? We use these cables here with concrete girders. There's two types of bridges, the steel bridges, concrete bridges. Concrete ones we have to put these tension cables in. We use these jaws right here, Dean. And we put them in this press. We have to raise this head up and we pull it. And we don't bust the cable, we just take it up to 41,300 pound load. Now this is our new press here. We just got in for testing fabrics. We test fabrics and also geogrids.
What's a geogrid?
Okay, on West Valley Highway we dug out 4-foot trench that was clay, and then we put this down and the fabric, this kind of fabric here underneath it, and we saved a foot of gravel putting in for fill, so it saved us a lot of money. This gives you strength here. You can see you can't even pull it with your hand. It's real strong stuff. This stuff is almost as strong as steel, and we have to test that in here. We test different fabrics, and we've got about 4 different thicknesses of fabric, and then we got another one here. This one here is used for a swampy area.
Keep weeds out.
How they discovered how this stuff worked was a farmer in Georgia was feeding his turkeys with some feed, and he's throwing his empty plastic sacks behind his barn, and it was swampy back there, and he noticed when he drove his tractor in there, his tractor drove right over it without getting stuck. So he told these fabric companies about it, and now we use this for slope protection on our slopes on bridges in I-215, and we use these out at Great Salt Lake. It stops the water from eroding the soil behind the rocks. You can use that behind rocks. This is called a woven fabric, this is called an unwoven fabric. We have about 5 or 6 different tests on fabrics. We have a grab test that's on there on that press. Then we have a trapezoid test. We have a Mullen burst test that represents your elbow going through here. It's got a hydraulic pump on here. And that tests a puncture test. And then I've got a rod here, and we put a fabric inside here. You can come over here and take a look at it, Dean. It's got a fabric in there, and this is a puncture test. And then we've got one last test here is we fill this up with water. And then what we do, we take a little clock, and I got that little watch there. We time it from this spot here down to here, and it tells us the permeability of the fabric. See how fast the water goes through. Some fabrics you want the water to go through real quickly, and some you want to go real slow. Okay? And we also test in here fence posts. Here's a fence post the farmers use. Right here, this green one here. We have to measure it, weigh it up, divide your weight by your foot length, and that gives you your pounds per foot. And there's 2 kinds of posts. There's a cheap one the farmers use at 1.25 pounds per foot, and the state one, federal government one, is 1.33 pounds per foot. We test chain link fence. We test farm field fence. We also have to test the reinforced mesh wire that put in noise walls and median barriers that go in the middle of the freeways. I cut a piece out like this, put it in these jaws here. We put a piece in here with a T on it, put it in here, put it on this press, and pull it at a certain load Usually on all wire and steel, dog bones, we have to have 0.20 inches per foot when we test the steel. And we have all these books here for all the specifications, and also the AASHTO specs. We have two specs, the AASHTO specs and the ASTM, American Society of Testing Materials. And I have to have these memorized, and I have to know how to test everything for their freeways. On our multi-plate pipe, we make dog bones, put it on the press and pull it in half, and there's a sample of one right here. Okay. Now,
What size of cable is that? 5/8 or half inch?
that's 7/8 inch. Now, every 2 years, we have a Bureau of Standards in Washington, D.C. send out a guy, and he spends a whole week in here, and he checks me out to make sure that everything I do is kosher. And I'm certified every 2 years. And it's a real tough test because he asks me all these questions, and I have to know them all, and I have to know all the calculations on any questions he asks me. And we got one of the finest labs in the United States. We've got the latest computer press here. If you notice on this press here, come here, Dean, I'll show you how this thing works. Turn it on here. We got our own printer. This thing's got a Pentium in it, the latest Pentium, and it's got 166 megahertz on the hard drive. It's real simple to operate. We got a 3.1 on the Windows on the computer. Then it's got a password in there, so I just put my password in there. Okay, it says to unload any specimen on here.
Now, this isn't a press, is it?
This is a press. Yeah, we call this a press. Okay. Then it turns it on, and then it's gen test, run procedure. Then I hit this down to the one I want for a geogrid, dog bone epoxy geogrid. I can hit that. It goes into my geogrid. And then I can tell it what kind it is and everything about it. Put in the, on a piece of fabric like this, all you have to do is you measure with a micrometer the thickness and the width, put it in here, and there's a little teeny Jap in there and a little typewriter, and he sits inside this here little machine, and he does all the calculations. All I have to do is tell him the thickness and the width. He multiplies the width times the thickness, gets the area. I pull this thing here. When I get my load, it automatically divides the area into your load, and that's what you do with everything. All you have to do is know the dimensions of a material, and you get your load and divide your dimensions into your area. You figure out your area and divide it in your load, and you always get your PSI. Okay? And that's how we work this machine here.
Now, you keep saying we. Is this your lab?
This is my lab, yeah.
So you're the one that put these deer?
Pardon?
The deer here?
Yeah, those are my deer.
The deer and that's the deer.
Okay, I'm exiting out here. Okay, there we go. That's about all in here, Dean. We'll go quickly through the other labs. We use these jaws to test the rebar. We have to drop this head out, put the jaws in there, and we have to pull. Yeah.
Is this your original press?
That's the big old one, yeah.
They had to drop this in with a crane, didn't they?
Yeah, we dropped it through a crane in the roof from the other building. We use these small jaws for the small rebar, small sizes, and then the big one we use with this one here. Also, we have these bend tests. We make these coupons. They weld these coupons in 2 pieces together, the welders that weld our bridges. Before they start building bridges in the spring, all the welders have to be certified once a year for the federal government. So what they do is they make these coupons and they bring them in here, and then I put them on the bend test, and I run a root test and a face test, bend test, and it's got to bend 180 degrees without cracking. So I also check all the welders for all the state. Also for Syro Steel. I do work for the state of Montana, state of Idaho, and the state of Utah. So we do work for 3 states. And we have to write reports, and I keep them in my briefcase. And every time we do an inspection, we have to write a report, send 1 copy to the project engineer, bring 1 back here, and file it down there. And everywhere I go, I have to keep track in my diary what I do all day long. And then I put it on my timesheet. And then we have to charge the out-of-state states for time for my work. So I have to keep real good records all day long.
You know where we're going to go now?
We're going to just go into some of these other labs. We'll go into the sign shop next just for 1 second. Let's go. This is where they make the signs here. So they have the alphabets up there, and they stick these on here. And this is reflective tape. It's got little teeny glass beads in it. And they take photocopies here, and they make all their signs right in here. And he's doing a layout here right now. Here's the sign he's making right here. This is my son, and this is my twin brother from Canada.
Hi, how you doing?
He just wants to see the sign shop. Before I retire, he's going to have me a video. I'm retiring at the end of the year. So he's videoing. Yeah. So he's videoing everything. And these are the scraps they have left over here. And remember yesterday when I went fishing, I used some of that green reflective tape on my pop gear. I caught all those fish. This stuff really reflects good on the lab, and they do research on asphalt cores in here, on the MTS.
Didn't you used to do that?
No, I never. That's research. I have nothing to do with him. Yeah. These are the guys I work with. This is Bill, and this is Gary, and this is Red. This is my twin brother Vern from Canada.
Hi.
This is my son. He's videoing everything for my retirement. So we're going around to different labs.
It's actually a duplicate of you, though. Huh?
Yeah.
We have been working on this for many years. We cannot imagine
You're right, there isn't.
This is our copy machine. We have to copy all our reports and put them in the basket in the morning.
Okay.
And over here's our
Fax machine.
fax machine. We fax out reports to project engineers if they're in a hurry to get a report. Okay. Curing room. When we make the cylinders, we have to keep them in here for 28 days exactly, and then I bust them. And so on the 5th, we break these 2 sets. On the 6th, we break these 2 sets. And we have to have 95% humidity all year round. So we have water running here day and night. And then we have to have a temperature of 76 degrees plus or minus 5 degrees. So this water cools this room and keeps it at a certain temperature.
Now, does this simulate rain? Is that what this is?
No, it just cures the cement. It's a curing process.
Oh, okay.
It keeps the cylinders at a certain temperature and humidity so they all cure the same
Okay.
for 28 days. We only got about 3 or 4 labs here and we're finished. They did a nice job on this hallway for you, Vern. Just one. Ron.
Yes, sir.
You got a minute?
They're busy.
This is where they test soils.
Yes, sir.
This is my twin brother Vern, and this is my son, and I'm getting a video done for my retirement before I leave. Can you tell them a little bit about what you're doing here?
Sure. We do nothing. No, actually what we're doing in here, this is, well, you should call it a foundation, but now they're geocache. And what it is that we actually run tests on material that's going to be for structures or slope stability or things that need us to find out what type of material it's going to be or how far down
How
they
many
need to
feet
go.
down do you go for
Yeah,
a core sample?
It depends. It can vary from foot to foot. They can go 100 feet and have different type of material, then they can move over 20 feet and go down and get another source of material.
Most of it's for
Yeah.
bridges, isn't it?
Bridges
Soil
on slope stabilities.
Yeah? Oh.
Yeah.
How many different types of soil is there in Utah?
Well, we used to have, they've got a new system on it, but it used to be A1A material clear down to A7, 6, 20.
So we got clays, sand.
You got clay, sand, silts, rock, organic, what else? What else would we have? Yeah. That's about it. But like I say, we do have a difference in this state in the fact that we can go from a matter of 10 feet from one source to another and come completely with different type of material.
Wow. Now,
So
you test aggregate too. What do you do
we
for
test aggregate.
test?
What we test aggregate for is mostly for strength. We run a test that basically has steel balls that break it down to see how strong the actual aggregate it is. We have tests that run and see what the freeze thaw, how it affects the freeze thaw over the years. We have tests that will check the densities of it. We have tests that check the specific gravities. We have a test now that we're real heavy in. It's called the polish test, and basically what it is that we're actually running a tire wheel over samples that have been made up in coupons, and we test the actual friction of what that
Wow.
material takes.
Now you test aggregate for asphalt lap sometimes?
Yes, that would be Pacific gravity, soundnesses.
Then you test aggregate
waters.
also for our bridges,
Yes.
concrete bridges.
And mostly that is just to see what the type of classification as far as gradations.
Gradations.
How much
How many
material.
different kind of gradations is there in the aggregate on the sample for concrete?
Well, we just run two. We run one for a plus or a minus material, and then we just have a series of sieves that we use for each one of those.
Okay, very good.
But that's it.
What's the most depth you go?
What's the most depth that we have gone? Most of the bottles that we've gone through are down to about 100. You think you see anything different? We can go, of course, down lower than that.
Use the gophers?
Pardon?
You use the gopher in case you hit rock?
I don't know what they use. No, it's just strictly, it's just a
They just
drill
use a
bit.
tube.
It's just a,
Have you got one of those drill bits you can show
well,
them?
we don't have the drill bit, but this is what they
I mean the drill, core.
This side.
Here's a core. And then they cut them off and put them in these here. And they,
No, those are Shelby's. Those
These
are
are Shelby's.
hand
Shelby
samples.
core.
This is what they actually put the samples into,
Oh,
and they put that down into the ground.
They got these big drill bits they connect up. How many length, what's the length in those bits?
Those rods,
Rods.
probably 10 feet each one, maybe.
They screw them together, don't they, or something, and then
yeah, they're like
they keep adding on, drill
Keep
down.
adding that. And they usually have a geologist with them who tests the material. They have water that is constantly coming out, and he's checking what this is.
So it's a 4-point or a 5-point bit that screws on the very end when it starts drilling.
He doesn't know.
Yeah, I
Now, see, I'm with a utility company in Canada, and I work for a gas company there. They use gophers, and they also use the same system with the drilling too. 3/4 inch.
Did you get a picture of some of their equipment there that they use?
Yeah.
Okay.
But it must be in a similar line as this system. Usually the times that we've seen the builders or go out with the builders.
I'm going to do recreation research. This is where the aggregate is in there. The piles of gravel. He tests out. Aggregate is gravel, stones. Okay. Yeah, this is another lab here. Hi, Michelle. This is my twin brother, Vern, from Canada, and this is my son. They're videoing for me before I retire all the places I worked. Hi, Steve. How are you doing? This is my son. This is my twin brother, and they're making a video of me before I retire here at the end of the year.
They're making a video of you?
Yeah. Steve, can you tell him a little bit what you do in here?
We do bituminous mix design in here.
Just sit.
We do bituminous mix design in here. We make samples like this and we test them. This is actually a mix out of a road, and this particular job is from Lambs Canyon to Kimball's Junction on I-80.
Where we drove down from Park City the other day.
Where that construction was.
This
Where you
is a
saw that?
sample from there.
This is a sample from that road, and we're testing it.
About 4 inches.
Yeah, this is a 4-inch round, and it's 2.5 inches in thickness. And
What are you going to do with that?
we're going to test it. We're going to test it for air voids. We're going to test it for stability and flow, and for the voids in the mineral aggregate that are in this mix. We also made, hold this a minute. These are Sharp's gyratory samples, and these are 6 by 4.5. And this is called the Strategic Research Highway Program. This particular sample is from August 13th. It's brick number 1, and it's lot off of the job number 19.
You put it in that big machine over there?
No, I put it in the blue one.
On the blue one? What's it do there?
It compacts it, and it gives me a printout over there on that printer. Tells me what the density is at as it's compacting, tells me what the density is as it's compacting.
So you compact it right here.
Yep, compact it right here.
All right. Now, when you finish the job, like, do you make a core and bring it in here to see if it comes out the same as what the design was?
Well, see, that's what we do. This is mixed from the road.
You got the mix from the road.
Yes.
And you'll compact it ideally.
And then we can compare it against what happened, what the original design was. That's
Right.
the purpose
And
of
see
what
if
we're doing.
It comes up the same.
See if it comes up the same.
Now,
Wow.
was that cut right out of the road? Did you drill the...
No, this
No,
is
no.
mixed taken behind
stockpile.
the laydown machine.
okay.
You know, it's the laydown machine is laying that mat out. They go up there and they take the sample out of the road. I don't go up there every day. They save samples. I just went up there yesterday.
Hey, Terry,
I've got to test all these boxes that are right here.
can you
full of
go in your
mix
paint
for the
lab and we
days that they
can
were
talk
done.
to you for a minute? You got 5 minutes? We can come into your lab and you can tell
I
them
don't
what
know
you do in
what
the
else I
paint
can
lab.
tell you.
This is for me.
We noticed yesterday up there on I-80 that it looked like a couple of the lanes had the trucks had pushed the asphalt down and it caused actual grooves with tires.
That's called rutting.
Yeah,
That's
how
called
does
rutting.
that happen?
Too much oil or not the right design?
They might have put the trucks on there too quick. That's usually the main problem.
Much weight.
Too much weight while the mix is right fresh. They'll take care of that. That's still got a seal to go over at the top of what's happening up there.
Supposed to put another coat of asphalt on that.
So that will be smoothed out. And we do other kinds of testing here. We test for rutting. We test for
They got a rut machine over here.
we test for.
What is rutting?
That's what you were talking about.
when the tire sinks
Is that
in.
a test for that?
Yeah, we have a test for that. Too bad I don't have any samples in here
Now,
right
do
now.
you make
to look at.
your own designs in the wintertime when you have free time? Make new designs for the next year?
Well, not for the next year. What we do is we test designs and we test new procedures to see if they're going to work and what corrections we need to make.
And you're always open to new equipment, right?
Oh yeah.
They're
In
getting a
fact,
big new piece of equipment here.
yeah, and then there'll be 2 pieces
Colorado.
of equipment. One will sit in here and one will fit over there. Actually, it's being made in England.
Is it?
Uh-huh.
Wow. Thanks, Steve, for your time.
Okay.
You got a good lab. This?
Well, I don't know, this is pretty messy.
Okay, just tell them
No job is clean.
what 2 types of traffic paint you use usually.
So this is the paint lab.
Yeah, they test the paint.
You test paint there.
Go ahead.
Okay. Well, we test solvent-based paint and epoxy traffic paint. We test all types of pavement marking tapes. In here, I test all of the physical tests, the weight per gallon, pigment percent, solid percent, viscosity. I have.
You show them the viscosity machine. Tell them a little bit about it.
Yeah.
Right here.
This is our viscometer, and this tests how viscous the paint is.
Put a can of paint inside here, put the propeller in there, and it spins around.
Stir.
Yeah. Then I have a centrifuge, and what that does is that separates the total non-volatile from the pigment percent, and then I put it in the oven for 3 hours, and that tests, and it gives me the percent solids and the percent pigment content. And then we have a specification, and then I compare it against the specification, and that determines whether or not the material meets or does not meet.
Do most materials pass your tests?
For the most part, we haven't had a whole lot of failures. This year on our solvent-based paint, what we're going towards a more quality assurance instead of quality control. So what I do is I test the viscosity and the weight per gallon, and if that tells me, if I get some of the same results that compare to the manufacturer's certificate test, then I don't go through with the complete physical and run the solids and pigment percent. We don't. No.
You test the primers for.
I test a primer. That actually is a federal standard that from AMRL, but one of the tests that we have to go and compare against all the other paint labs just to see how well we correlate. So that is an oil base.
That is an oil base. The rest is your water base.
We haven't started testing any of the water base. We're just in the process of, we purchased a new water based paint truck, and so we're gonna, as soon as we get a spec, we will start testing the water based.
How that's going to stand up for the weather conditions and whatnot.
Right.
It'll be interesting.
Yeah. We're expecting that, we're comparing it to the solvent base, which is replaced anywhere from 2 to 3 times a year. And we've had a water base that we've had the industry say that it'll give us a 1-year life. And about 3 weeks ago, we went down to St. George and we did probably about, I would say 50 to 60 road miles of material. And we'll go down and track it every 3 months to see what kind of life we'll get.
Can you tell them a little bit about the glass beads?
Yeah, our glass beads, and I don't know if you want to come over and get on.
This one right here.
Okay, this is a Visibead, and this is actually what they use for epoxy traffic paints. It's a larger bead, and this gives your nighttime reflectivity, and this is placed on top of the paint at the time of placement. The Visibead is placed at 25 pounds per gallon, so they're flooding the paint, and the epoxy paint is 25 mils thick, anywhere from 22 to 25, and the beads, what they do is they fall down into the paint, and as it wears, you're constantly exposing new beads as they wear off.
How much of a stripe does the bead get? On a plain stripe, when they put the paint down, how much beads?
Beads?
The whole stripe or half the stripe?
They do the whole stripe.
Do the whole stripe?
Mm-hmm. Yeah. That's what the Visibead.
And what tests do you run on the beads?
The beads, we run gradations like you do on your sand and gravel. They have to be a certain size. It goes down to a size 12, or it starts out at a sieve 12 and then goes down to a finer bead.
You were saying about that, getting back to the white water-based paint, you're going to test it as a guarantee for 1 year.
1 year, and what we go out and test is we've got an instrument that tests reflectivity for the bead retention.
2 suitcases in my lab.
How is that compared to the oil base?
To the oil base?
No.
Or the solvent base?
base.
The solvent base is we're replacing it anywhere from 2 to 3 times a year. So,
The water's gonna actually be better.
Better.
Wow.
and
No,
certain conditions. They're
You're gonna
looking
get a sample from the state of Texas. They made their own pro formula and it's really good.
for the water base.
Yeah, you might try it.
So at the same time, you.
We put down 300,000 gallons in Utah, and Texas puts 3 million gallons down. And they've done a lot of research, and they made their own formula, and there's a factory in Texas that makes a real good traffic paint.
This is our solvent-based bead. And you can tell the difference and see how much finer.
It's a lot finer. It's not as coarse.
When we went down to St. George to test the water base, what they did in the water base is they put the Visibead in it. But what was happening is the water base material has such a quick dry time. They're
Is that
looking
right?
at like 30-second dry time.
Wow.
So the bead is not adhering to the paint because it's drying so quickly that the bead is just blown off. And so their reflectance actually was below a federal standard of 150. It was well below that. And I think it was just because the bead retention wasn't adhering to the paint. So one of the recommendations that was recommended from Tim Rose is to possibly go with the smaller bead to get the retention.
Actually, with that water base, it's better for your environment, killing 2 birds with 1 stone.
Yeah.
What's a figure for reflectivity off the top of your head that you use with that suitcase? What kind of reading do you get? What do you call that reading?
Okay, well that's called it's a millicandela is what it is read in, and
So many candle power?
it has so many candle power. And what it does, it has its own light source, so you can test it during the day, and you take your reading. And we've got 2 types of instruments. I don't know if Vic had showed you.
Yeah, I didn't show the inside, just
But
on the box.
they have the Miralux, which they're looking at getting away from, and we're experiencing higher readings using the Miralux versus the LTL. The LTL is in 30-meter geometry, and so they're looking at the reading in the LTL is more to the driver's view at the 30-meter, and so it's going to become a federal mandate that they start using the LTL with that 30 meters. So
Now, yesterday, when we were going up to Park City the other day, we saw a federal van, a black one, and they had a box screwed on the side of it.
Yeah.
Did you get those guys?
That's the
Can
mobile.
you do that to yours?
Well, that's the mobile reflectometer.
Can you get one like that?
Well, the
That costs a
state,
lot of money.
the state actually 2 years ago approved the purchase of one, but they ended up using the money for something else at the time. But
That's where I got my press.
yeah, that's right. That's where that money
Well,
went.
thanks for your time, Terry. Appreciate you. You're doing a good job. These are the paint samples she gets in cans and stuff. Hi, Roy.
Hey,
How are you doing?
good. What do you got?
This is my son,
How you doing?
and I got my twin brother visiting me, and he's taking a video of me before I retire at the end of the year.
Are you gonna retire already?
Taking a fast view, the end of January 1st.
You just decided that you're gonna
I
retire?
don't know, I've been on this for a while. I got 30 years.
Oh
Anyhow,
my gosh.
can you tell us just a little bit what you're doing here?
Oh, this is where we
Just a
test.
fast one. Yeah.
This is where we just test all the binder asphalt,
Yeah.
and which is just the asphalt before they mix it with the aggregate to put down on the road, and we test the tack oil too, and we kind of simulate conditions, of the asphalt once it goes through a batch plant, and simulate what happens to the asphalt after a
How
period
many
of
different
time.
tests do you do on one sample?
On one particular sample, there's it depends on what kind of sample it is. On a basic AC20, we would run maybe 9 different tests.
You run a tensile strength test?
Yeah, we run a TNT, viscosity. We run a kinematic viscosity, RTFO, ductilities, penetrations, and just a few things.
You have many failures?
Oh, we have quite a few. And when we do, we always assess the price adjustments. We let the contractors know.
Cost reduction.
Yeah.
Have you had much to do with the work on Lambs Canyon this year?
Yeah, we're testing all of their asphalt cement, and we're using the Sharps specifications on that.
How are they passing? Pretty good?
They're doing really good. Coke has a really good product.
Is that right?
Yeah. We'll
What
see
percent
how.
oil do they put down on there?
I think they're using 4.5. I'm not sure.
4.5%.
I think so.
This is some of your equipment here. There's Dean. Dean, just take a shot over there. This is Mike. He's my friend. He lives not far from me. He works in the lab here too. Mike, this is my son.
Oh,
And my twin brother's visiting with me.
Twin
and I'm
brother?
retiring at the end of the year, so he's taking a video of me before I leave. Yeah.
identical twin?
No, he should be around. I don't know where he went to. This is the ovens, and this is the viscosity machines they use. And
He's going to retire at the end of the year. That's why he's doing it.
yeah, these are our new federal sharp machines here. See, we got computers on them over there. Can you get a shot of that, Dean? Come here.
Yeah, I got it.
Right there. And they got the bass. And then these are all the samples from the freeways that they test right here.
We gotta find your brother there.
Okay, that's it. Thanks, Mike.
Which one?
My youngest one. And
Okay.
I got my twin brother here from Canada, and we're visiting the labs, and he's recording everything for my retirement. And I just want you to tell me just a little bit about some of the tests you do here.
Okay, I'm presently running and verifying with a calibrated thermometer for the autoclave, which measures the expansion and contraction. And this test here is part of it. This is the flow table. This measures
Have you got a
how much
sample
it
of your
goes
cube
out.
and your autoclave that he could show?
A cube?
him?
Yeah.
What
there's
is a cube?
Okay. Here's the expansion test he puts in the autoclave. I used to make these.
So that's concrete, not asphalt.
This is just plain cement.
Cement.
That's what they call
Cement.
a neat cement.
Concrete
Just cement
is when you put aggregate and sand in with cement.
Oh, okay.
He just tests the cement powder itself in this lab. This is called the cement lab. This is the autoclave expansion test. And then where's your square cube, Russ? Have you got one here?
No, I don't, but I have them in the.
That's fine.
Well, he's got them in here. And what he does, he mixes up a batch with a mixer, makes these little cubes, and he cures these how long before you break them?
3 and 7.
3 days and 7 days. And he puts these in water,
Lime water.
lime water. And it has to have what kind of humidity? What
90.
percent humidity?
98%.
Okay, and what about
Minimum.
the
Is that to
temperature of the
simulate
water?
rain?
Pardon?
Is that to simulate rain?
No,
Is
no,
that what-
No,
just-
it's just to...
just to cure. It's a curing
cure.
system.
Oh, okay.
What temperature do you need? 76
For the water,
degrees plus or minus 5 degrees?
it's 73.4
3.4.
plus or minus 3.
3, okay. And you get samples from where?
Devil Slide Mountain, California, Nevada,
Idaho?
Colorado, Idaho.
Idaho. And these are samples he samples and he tests. Oh, besides cement, what else do you test in here?
Fly ash,
What tests do you run on fly ash?
density, 325 sieve, which measures the fineness, and 28-day pozzolanic activity index.
Now, have you
and
had
the
any?
water content.
Have you had many failures on fly ash?
You always get failures on anything.
What about cement? You ever
It's-
have many failures? It's pretty good stuff, though, isn't it?
It does
You have
fail.
pretty good control on that.
It does fail, but usually it's
Very
a
minimal.
sampling problem rather than a cement problem.
Is it? But they know you're testing, so when they know you, a good guy like you's testing it, then they do a good job at the factory, right? If you wasn't here to test,
That's optimum thinking.
if you wasn't here to test, we wouldn't have very good cement in Utah. And Russ has been working here how many years?
Well, I don't know. More than one and less than 10.
Longer than him?
Oh yeah.
Because he's going to retire.
I worked here. I worked in this cement lab 3 years. This is where I started out, was cement lab, and then I worked in physical lab.
Well, you started in this cement lab.
I worked here for 3 years, and then I worked 27 years in the physical testing lab. This is where I started. This is the molds they used to making the cubes. Look through here, Dean. The door's locked. Hi, Pam. This is the environmental room. In this here room here, there's an ozone tester, and it tests the paint for for the sun, the durability of the sun. And then we got a big environmental chamber here that we can test with freeze-thaw cycles for concrete or asphalt.
Okay, that's it.
This is the chem lab.
What? Hello?
This is my twin brother, and this is my son, Dean, and I'm retiring at the end of the year, and I'm just taking a video of where I used to work.
Okay, this is the
What test
chemistry
do you
lab.
run here?
I do cement analysis, I do lime, hydrated lime, I do zinc for Vic here, and zinc platings. That's mostly what I do.
And what are these machines over here?
This one's an IR, infrared spectrometer. This is a gas chromatograph, and the last one over there is an atomic absorption spectrophotometer. There we go.
How long have you been doing chemistry tests?
About 5 years.
5 years?
Now,
How do you like it?
What's the purpose of the chemistry test? Is it to test for sun or
Yeah,
salt
right.
or
No.
No,
She finds
we
out
do-
what elements there are. Like she
Oh,
gets a
okay.
cement sample in here. She finds out what the different.
I find out
That's
what
what's fun.
different elements or different compounds are in the cement to make sure it meets the specifications.
Same with fly ash. Do you do
Fly
any
ash, yes, I do chemical.
What about
on-
paint?
I do some chemical on paint to make sure that the amine and the epoxy content are what they're supposed to be.
And you said you did zinc.
Now, once a month, I go to 3 places. I go to Cyro Steel where they do guardrail. I go to USA Industries and they do chain link fence. And I go down to Intermountain Galvanizing down south, and they do all kinds of steel beams. And I take 3 little core, dip out 3 samples and make core samples. And I bring them in here, and then she drills them with a drill, and then she puts them in here, and she gets a chemical readout of the chemicals in there. And on a zinc sample, we have to have 98% pure zinc. And so once a month, I go up to these places where they dip fencing and stuff, and they don't know when I'm coming, and then we keep them honest by having 98% pure zinc on all our lamp posts and all our fencing on the freeway.
So what I do is I test for the copper and the iron and aluminum and cadmium.
Those 4 elements,
And if they add up to less than the 2%, then we're fine.
we're fine.
You have to break them down into liquid.
I digest.
Okay, that's good. Thanks a lot. Okay, Dean, that's it.
Okay.
We're going to take a shortcut through the machine shop, and then we'll get in our car, and then we'll go back to my lab. I want you to take a picture of the machine shop. Flashing lights, we've got a place down there
Just
that
clip it on
does
your
it.
shirt.
And then we
When
have,
you move it around, it hears it. I can hear it popping. It's best to just clip it on.
Bring your phone.
and then we have a vehicle shop there, and then we got a truck shop. And in here, they fix the big trucks in here. Yeah. So
Same as ours.
if my car breaks down or something, I can get it fixed in 2 days. We got our own mechanics. This is a weld shop. They weld all the truck beds for the trucks, and the salt deteriorates the beds, so they have to keep welding the ends of the beds. So that's where they work. Hi, Lynn.
Hello.
This is Lynn Meekum. He's the smartest guy in Utah. He does all the machine work for our labs and also for the snow trucks. Keep going, Lynn. This is my son. This is my twin brother. We're taking a video before I retire.
Well, I'm sure glad that he's a good looking one. Thank you.
This is a drill press. We bought this from surplus from the feds. How much did you pay for this big press? $1,000.
Well, this is the best one here, this green one. I give $100 for this one.
For that one? Wow. I know.
Only $100?
We get it from surplus.
Surplus, both of them.
And then
This
he,
one they ship from Hawthorne, California.
wow.
Comes from northern Bay.
It does every angle, and he's the guy that drills my rubber pads for testing my concrete cylinders. Lynn made a jig for us. He's pretty smart. He does all inventions for us for all our problems. He helps the asphalt lab for Steve, for his lab.
I'll haul that in by a low boy.
So we can make anything we need for our labs by just talking to Lynn, and then he gives us his ideas and we come up with some real good savings. He saves the state thousands of dollars. Yeah. Hi, Ron. These guys. Did you take a picture of the old van there?
There's the van.
It's my beautiful van.